Yeah, welcome back to the Algebra 2 jungle, and tonight we're going to tackle some complex fractions, and not the nicest sounding topic you've ever seen. We generally don't get excited when the word complex is in our title, but they're really not that bad. They're certainly not as bad as they look. So here's an example of what one of our problems is eventually going to look like, and we'll tackle this one later in the video. But we're going to fill in a really quick definition here, and first things first, we're going to say that a complex fraction contains one or more fractions in its numerator, its denominator, or both. And that's what you're seeing in this example that we printed up here was here's your numerator, and you'll notice there's actually technically what we'd call three minor fractions. Now, what is a minor fraction? A minor fraction is anytime you have a smaller fraction within the larger whole fraction. And actually, even this term's a fraction because it's technically could be expressed as 1 divided by 1. And then in the denominator here, we've got two minor fractions. And kind of same idea where we could express this as 1 divided by 1. So grand total of 5 minor fractions, and we're going to talk about how to combine them and simplify these expressions tonight. One of the things I noticed as I was preparing for this video tonight was I think traditionally I usually solve a lot of my problems going down the page, and tonight I found it easier to solve everything moving sideways. So I'm going to try to squeeze these in the best I can. The first thing I want you to see is that here's our big main fraction bar. And what I'm going to do is I'm going to rewrite that as a division sign. So I've got the first fraction divided by the second fraction 9/10. And what we learned the other day is a trick called keep, change, and flip. And so when we keep, change, flip, just like it sounds, we're going to keep the first fraction as 1/5. We're going to change this operation to multiplication, and then we're going to flip the second fraction, or in other words, take the reciprocal of it. And here I'm going to just reduce anything that can be reduced. I know that both of these numbers here are divisible by 5, and I'm going to go ahead and multiply across, and 1 times 2 makes 2, and 1 times 9 makes 9. So my final answer here was 2/9. Now, quick review there of everything I did. I think my favorite move right off the bat was what I did very first is I took instead of stacking the fractions like they did here, I wanted to express them using this division sign right here, and I think that's going to be a really positive move for us tonight. Example number 2 is a little more complex than the first one because now I've got two minor fractions on top and two minor fractions on the bottom. So what I'm going to do is I'm just going to find a common denominator for these two minor fractions on top. And when I consider the 2 and the 3, I would do a common denominator of 6. Which means this one gets multiplied by 3 over 3 to make a numerator of 3, and this one gets multiplied by 2 over 2 to make a numerator of 4. And if I combine those two fractions, I get 7 over 6. Alright, now, on the denominator, I'm looking at a 4 and a 6, so I think my common denominator is going to be a 12. It means this guy gets multiplied by 3 over 3, so I got a 9. This guy gets multiplied by 2 over 2, so now I've got a 10. And if I subtract them, I get negative 1 over 12. Now once I get here, I'm right back to where I was on the first example, and I'm going to rewrite the division as 7/6 divided by negative 1/12. From here, we'll do a keep, change, flip. One of our popular tricks. The negative sign usually stays in the numerator. You just flip the rest of the fraction. You could reduce just a little bit and make this a negative 2. Multiply straight across, you'll get negative 14 over 1, or just negative 14. And that's all there is to it. Now here's the great news in this third example is that you're seeing only one minor fraction in the numerator and you're only seeing one minor fraction in the denominator. So I'm going to automatically rewrite this using a traditional division sign. There's my traditional division sign, 6 over bx. Notice I haven't reciprocated anything yet, but I'm going to do that now, and I'm going to do keep, change, flip. Keep the first fraction, 3 divided by ax, change the operation to multiplication, and flip that, or reciprocate that second fraction. Okay, now what I'm thinking is let's reduce the 3 becomes a 1, 6 becomes a 2, x divided by x is a 1, and I think that's all I can reduce. If I multiply straight across, 1 times b is b, and a times 2 is 2a, and ladies and gentlemen, we just simplified another complex fraction. Now the number one thing I want you to notice in this example here is that when you look at the numerator, how many minor fractions do you see? Hopefully you just said 2. And I like to rewrite this as 1 over 1. And when you look at the denominator, you see 2 minor fractions as well. So what my first goal is to find a common denominator just for the numerator and combine these 2 fractions into 1 fraction. That's my goal. And I think my common denominator is going to be a 16. So keep the first fraction exactly the way you see it, and then multiply the second one by 16 over 16 to get, well, 16 over 16. Okay? Now, in the denominator, we're looking at an 8 and a 2. Same idea. I want to create a common denominator. In this case, I'm thinking 8. Let's see. Keep the first fraction as x over 8. Multiply the second one by 4 over 4. And let's see, we're going to slide the screen over here a little bit. If I go ahead and combine these 2 fractions right here, I would get x squared minus 16 over 16. And if I combine these two, I'll get x minus 4 over 8. And now, I love where I'm at right now because I've got just 1 fraction on top, 1 fraction on the bottom. So I'm going to rewrite this as a traditional division. X squared minus 16 over 16 divided by x minus 4 over 8. I'm going to do keep, change, flip. Change that. I got the 8 on top, x minus 4 on the bottom. Now, as I try to reduce this one, I'm going to make sure, this is the first time where this has been the case where I've needed to worry about this, is I want to make sure everything's factored. And so ask yourself this question, is everything factored? And you'll notice that the x squared minus 16 is not factored as much as it could be. So I'm going to do a difference of 2 perfect squares. The denominator there is still 16. Second fraction still has an 8 over an x minus 4. Now all we get to do is, our favorite part is we're going to cancel any like terms here. 8 divides into 16 twice. So when I'm all done, I get x plus 4 over 2. And that right there is my final answer. There's nothing, I cannot cancel the 4 and the 2. The 4's in jail, so to speak. And if you want, you can put parentheses around it. And the parentheses are like, you know, a jail cell that says I can't cancel the 4 without including the x. Okay, so really we haven't taken hardly many notes tonight. We've just been grinding through some examples, and I think it's time to kind of summarize what we've been doing and do a quick overview. And I think as I'm describing these steps here, I think refer back to our last example and see if it makes sense that, you know, see if you can draw some connections between what we're saying here and what we did in the last problem. So the first thing we're going to do is find a common denominator amongst all of the minor fractions in just the numerator. Notice we're focusing on just the numerator. And then combine them into 1 fraction. So I'm trying to combine all the minor fractions in the numerator into 1 fraction. There might be 2 minor fractions, there might be 3, there might be 4, who knows how many there's going to be. My goal is to get a common denominator and combine them all into just 1 fraction. Okay, step 2, find a common denominator amongst all the minor fractions in the denominator this time, and then combine them into 1 fraction. So you might have 2 minor fractions in the denominator, you might have 3, you might have 4, who knows. Our goal is to create a common denominator and combine them all into 1. And then we're going to do a little keep, change flip action. After you do keep change flip, ask yourself if everything's factored. Once everything's factored, go ahead and cancel and simplify. And that's all there is to it. Alright, another great example. We're going to try to put what we just wrote into action here. Right now I've got I'm going to rewrite that as 1 over 1. And I've got two minor fractions here. My common denominator amongst those two is an x. So I'm going to multiply this by x over x. X over x minus 2 over x. And if I combine those together, I get x minus 2 over x. So there's my numerator. In the denominator, I've got 1 over 1. Looks like my common denominator is going to be x squared. So I'm going to multiply the top and the bottom of that one by x squared. X squared over x squared minus 4 over x squared. Combine those two into one fraction. And we are cruising. So now we said we're going to do a little keep change flip. And I'm going to do it a little bit faster than I did in the earlier examples. So I'm just going to keep the top fraction, change this sign into multiplication, and then flip the bottom one. So the x squared's on top and the x squared minus 4 is on the bottom. Now ask yourself maybe the most important question of the night. Is everything factored? And the answer is not yet. Not yet. So I got x minus 2 over x, and then I got x squared over the difference of two perfect squares, x plus 2, x minus 2. Let's cancel the x minus 2's. And then we could say, now this x squared is really x times x. And you could say, okay, this x cancels the first one, but then you still have that one alive. And so my final answer is going to be x divided by the x plus 2 I have on the bottom. Don't cancel those x's. The x in the denominator is in jail, so you can't cancel it. And there is your final answer. Well, I'll tell you what, there's no doubt we got our hard hats on tonight. We are really grinding out a lot of examples. We're pounding through these bears. Now, if you look at these two minor fractions in my numerator, what would the common denominator need to be? So you notice we're getting slightly more advanced as we go. I think it's going to be the product of the b term here and the a term. So I need, I'm going to do a common denominator of ab for both of them, which means the first one gets multiplied by a over a, so the numerator is a squared. And then the second one gets multiplied by b over b, so that numerator is b squared. On the bottom, let's see, 1 over 1. I need, this one's much friendlier. I just need a common denominator of a, so I'm going to go a over a minus b over a. Now what I should do is just see, let's combine these two fractions into one. So I got a squared minus b squared over ab. And on the bottom I get a minus b over a. So we combined these two into just one fraction. And then we combined these two into just one fraction. Now one of my favorite parts, we're going to do a little keep change flip. So we got, whoops, that's an a squared minus b squared over ab multiplied by a over a minus b. Is everything factored? $1,000,000 question. Alright, so here's a difference of two perfect squares. So let's go a plus b, a minus b. I think everything else is already factored as much as possible. So we'll just rewrite the rest of the problem. And my absolute favorite part, let's cancel like terms. A divided by a makes a 1. And what should my final answer look like? Let's see, I got an a plus b on top. I got a b on the bottom. This b's in jail, so we'll just say there's my final answer. Final answer. By this point in the video, not a bad time to maybe try this example yourself and then come back, hit the play button, see if you get the same answer. What's interesting here, this is the first numerator so far that's had 3 minor fractions, and it looks like my common denominator is going to have to be an x squared. So I'm going to multiply by x squared over x squared, and this one gets multiplied by x over x. So I'd have x squared over x squared plus, let's see, 4x over x squared. And then the last term just stays as is, 3 over x squared. Squeeze that in there. Okay, on the bottom, 1 over 1. Let's see, I think I need an x squared again. So I'm going to go x squared over x squared minus 9 over x squared. We're going to combine these into one big fraction on top. So my numerator would be x squared plus 4x plus 3 all over x squared. The denominator, if I combine them, would be x squared minus 9 over x squared. Let's see if we can do a little keep change flip here. Boy, yeah, we're getting a workout tonight. There's a lot of math. There we go. Change it and then flip it. X squared on top. X squared minus 9 on bottom. Ask yourself the most important question here. Do I have everything factored? And so what I'm seeing right here is I've got a trinomial, and I'm thinking I need multiples of x squared, and I need multiples of 3 that add up to 4. So that would be x plus 3, x plus 1. I got an x squared, I got an x squared, and then I got a difference of 2 squares. So that feels like x plus 3, and if I can squeeze it in here, x minus 3. What can I cancel? Let's see. Let's cancel the x plus 3's. X squared divided by x squared makes 1. And when the dust settles, it looks like I've got the quantity x plus 1 divided by the quantity x minus 3. And there, ladies and gentlemen, is your final answer. Alright, well, congratulations on surviving to this point. This is our last example of the night, and we got just one little more curveball for you. What you'll notice is we do have a denominator here that's a binomial, and it's the first binomial we've seen in our denominator, but it's really not a big deal, and I don't think it's gonna be a piece of cake here. So if you look at these two fractions, these two minor fractions, they're going to have a common denominator of x plus 1. So we've got that. I'm going to multiply the first fraction by x plus 1 over x plus 1 to get this. And the second one's just going to stay as a 4. Okay, not bad. Now the one on the bottom here, let's put this over 1. Let's change this to a plus sign, and then we got negative 1 over 1, plus sign negative 24. And changing those minus signs to plus signs is going to pay off here in a second. And let's see, we're going to use a common denominator of x plus 1 for all three terms. And let's see, x plus 1 and x plus 1. Try to squeeze them in there. So now it's going to get a little messy here, but if we multiply the first fraction by x plus 1 and I distribute this x, I'll get x squared plus x. Now if I do the same thing here and I multiply by x plus 1 over x plus 1, I'm going to distribute a negative 1, and it's going to be negative x minus 1. So that's probably the biggest trick of the night, and then we're just going to keep the negative 24. So if I slide the screen over, let's combine these two fractions into just one fraction. So it would be x plus 5 over x plus 1. And then we're going to combine these three fractions into one big fraction. So let's see, I'm going to have an x squared. And then I think this positive x is going to cancel out with that negative x, and we just get negative 25 over the common denominator. Let's see, big move coming up here. Let's do a little keep change flip. Whoops, hang on screen. So we'll keep x plus 5 over x plus 1. Change to multiplication, flip the bottom one. And we got x squared minus 25. Make sure, let's recognize the need to factor that one. So we got x plus 5 over x plus 1 times x plus 1 over the difference of two perfect squares. And we'll cancel these two quantities. We'll cancel the x plus 5s. Now, here's a small technicality. When we said we canceled these two, we were really saying the quotient or the result of division is a 1. Cancel these guys, we get a 1. So now when I go to multiply, I'm going to do a 1 times a 1 to get a numerator of 1. and then the denominator would just be x minus 5. The key is the x minus 5 has to be in the denominator. We can't let it linger in the numerator, and that's my final answer. So hope you had some success tonight. We did a lot of examples, and if you're feeling uncomfortable at all, we're going to take care of that with a little more practice tomorrow. Okay? Hang in there. We'll catch you tomorrow.